Today, our focus is our 6 trigonometric functions in the unit circle. So most of you know sine, cosine, and tangent, but you may not be familiar with cosecant, secant, and cotangent. So in geometry, you use SOHCAHTOA. So you define them as sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we were to do that, and we're going to use angle A here, change my color. So we use angle A. Opposite is the opposite side. It's the side all the way across. Hypotenuse is always across from the right angle, and adjacent is the side that's closest. So we would define the sine of A as being the ratio of A over C. We would also define cosine of A is adjacent over hypotenuse, which would be B over C. And tangent is opposite over adjacent, so it would be A over B. Now, again, you probably know the sine, cosine, and tangent, but these ones on the bottom, you may not. Well, cosecant, which is the CSC here, is the reciprocal function of sine. So that just means it's C over A. Secant is the reciprocal function of cosine, so it's C over B. And cotangent is the reciprocal function of tangent, so B over A. Now, what tends to happen is people mix these up, which one goes with which. I always think of it as an S goes with a C, and that might help you figure out which one goes with which. But in trig, we're going to define them a little bit different. We are going to define them based on X and Y. So if you think about this being our coordinate plane here, the X value is along this positive X axis. The Y value is going up, and that's our point on our unit circle. Now, the hypotenuse is defined as that radius. So it's going to be the square root of X squared plus Y squared. Now, we can define all of these functions the same way. So this is still our angle A. This would still be our opposite side. This is our adjacent side, and this is our hypotenuse. So if we define sine then, sine we know is opposite over hypotenuse, which in this case would be Y over R. Cosine's adjacent over hypotenuse is just X over R, so on and so forth. So you can see that instead of defining them as A, B, and C like we did in the previous slide, we're defining them in terms of X, Y, and R. This allows us to do to evaluate different angles that you may not think of as triangles. So maybe those ones that are quadrantal angles. So our reciprocal identities, this is kind of what we talked about a little bit ago, that cosecant is 1 over the sine of theta, or alpha in this case. Secant is 1 over the cosine, and cotangent is 1 over the tangent. So we want to fill out our quadrantal angles. And this is where a lot of people have a little bit of problems. So when you talk about our quadrantal, those are the ones that are on the coordinate plane. So we have 0 or 360. We have 90. We have 180 and 270. So those are our quadrantal angles. Now, if we think in terms of triangles, we can't really draw these as triangles, but we can think of them as XY coordinates. Now, one thing that you need to know is your radius, because we're dealing with the unit circle, is always going to be 1. So here we're going to label this point. This point would be considered 1 and 0. This point here is 0 and 1. This point on the unit circle over here would be -1 and 0. So think of this as being on that circle if I were to draw that circle. And if I were to draw it, it probably wouldn't look very pretty. So we're going to leave it like that. So what I did is now I have an X value, a Y value, and an R value for every single point on those quadrantal angles. So if I'm doing sine, we know that sine was defined as Y over R. Cosine was X over R, Y over X. And then we do our reciprocals. R over Y, and then we would have R over X and X over Y. So that's just going to help me to figure out what these values are and to fill in this table. So if we are at 0, we are at the point 1, 0 with a radius of 1. so y over r. So we'd have 0 over 1, which is just 0. Cosine would be x over r, which is 1 over 1, which is 1. Tangent, y over x, so 0 over 1, which is 0. Now, our reciprocal ones, really you're just flipping those at the beginning, but we have a 0. If we flip that, we get 1 over 0. That actually makes it undefined. Secant would be 1 over 1 again, which is 1. And we'd have 1 over 0. So again, this one is undefined. Now, let's go ahead and go on and do 90. So the sine of 90 would be 1 over 1, which is 1. Cosine 0 over 1, which is 0. Tangent would be 1 over 0, which is undefined. Now again, we can fill in the rest. So we would have 1, undefined, and we would have 0. So again, you are doing those reciprocals. Now, 180, we would have 0 over 1, which is 0, negative 1 over 1, which is negative 1. The tangent would be y over x, so it'd be 0 over negative 1, which is just 0. Cosecant, again, reciprocal, that one's going to be undefined, negative 1 and undefined. And you can kind of see a pattern in what we're finding here. So with 270, we would have negative 1 over 1, which is negative 1, 0 over 1, which is 0, and then we would have negative 1 over 0, which is undefined. Keep going to fill in our table here. We would have negative 1, undefined, and 0. Now, 360 is really in the same position as 0, so we can just copy that top line and we would have our table completed. So those are the values for your quadrantal angles. And again, that's why our X, Y, and R allow us to do this, whereas we can't really draw those as triangles. So thinking of our special triangles. So we're saying we have a 45, 45, 90 triangle here. If we did our Pythagorean theorem, we'd get that this is the square root of 2. So if we find the sine of 45, okay, sine is opposite over hypotenuse, or y over r, we'd have 1 over the square root of 2. Now, we don't usually like the square root of 2 on the bottom, so we want to rationalize that denominator by multiplying the top and bottom by square root of 2. So that gives me square root of 2 over 2. Going to cosine, cosine is adjacent over the hypotenuse, which is 1 over the square root of 2, which again is square root of 2 over 2. And then tangent is 1 over 1, which is just 1. We can do the same thing with our 30, 60, 90 triangles. What they do is they give you a equilateral triangle, which is all angles are the same, all sides are the same. Then we're going to divide that. We're going to divide it in half. So we're going to make this a 90-degree angle on both sides. Then that divides this angle at the top also. So it divides this to be 30 and this to be 30. So now we have a special triangle. We know two sides of that special triangle. We can do the Pythagorean theorem and find that that is the square root of 3. Now, you have to look at this in two different ways. So we have the sine of 30 here. So we're going to think of this as our angle. So again, opposite over hypotenuse, so it's 1/2. And then we do adjacent, so square root of 3 over 2. And then tangent's 1 over the square root of 3. Again, we don't want that square root of 3 in the bottom. To rationalize that, multiply the top and bottom by square root of 3. And we get square root of 3 over 3. Now, to do these ones on the bottom, we need to look at this angle. So that kind of changes your opposite and adjacent if you think of it that way. So 60 opposite would be square root of 3 over 2. Then we'd have 1/2. And then we would have square root of 3. Now, if we finish filling this in, remember these are reciprocals. So this would be 2 over the square root of 3. But again, we don't want that. So 2 square root of 3 over 3. And we got that by multiplying the top and bottom by square root of 3. Then you have 2. And then you have 1 over the square root of 3, which again, we're going to change to square root of 3 over 3. So these are very common angles, and they're the angles that we're going to be dealing with, the 45, the 30, and the 60. So now we're going to talk about reference angles, and this is really our unit circle. Doesn't have the circle around it, but we're going to start here. This is going to be our 0 or 360 degrees. And remember yesterday we talked about it in terms of radians, that is 2 pi. So we have 0 degrees, we have 360, that's 2 pi. Now I'm going to go ahead and do our quadrantals. So we have 90. Remember that's also pi over 2. 180, which is pi. 270, which is 3 pi over 2. And so we have all of our quadrantal angles labeled. Now, I'm going to do the middle one. So we know that that's 45 degrees, and that would be pi over 4. Now, if I go another pi over 4, I'm at pi over 2, which is our 90. If I go another one, so I'm adding another fourth, that's going to be adding another 45 degrees, which is 135, which it's 3 pi over 4. So if you're thinking you're adding a fourth each time, adding another fourth, that gives me pi. Adding another one is going to give me a 5 pi over 4, or 225 degrees. Keep going. We add 45, we're at 270. Add 45, we're now at 315. But we would have 6 pi over 4 down here on the bottom at 270. And so this is going to be 7 pi over 4. Add it again and you are at 2 pi. So it's going all the way around by a fourth. So now let's do the 30 degrees. 30 degrees we know is pi over 6. If we go another 30 degrees, we're actually at 60, which would be 2 pi over 6, or pi over 3. We go another 30, we're at 90. Another 30, we are at 120, which would be 2 pi over 3, if you think of it. So you'd have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces to 2 pi over 3. Then we'd have 5 pi over 6, or 150 degrees. Keep going, we're at 180, and the next one would be 210 degrees. That's going to be 7 pi over 6. The next one would be 8 pi over 6, or 4 pi over 3, which would be our 240. Keep going at 270. Then we're at 300 degrees, which is 5 pi over 3. Add another 30, we're at 330 degrees, which is 11 pi over 6. So let's look at patterns within this unit circle. So if you look at the second quadrant, you'll notice that the numerator is 1 less than the denominator in terms of radians. So that will always be the fact, because you're just a little short of being 1. So you're 1 short of being 1. So the top is 1 less than the bottom. If you are in the third quadrant, you'll notice that the top is 1 more than the bottom. So, and that's all the case for all of those. In the fourth quadrant, you'll notice that the top is 1 less than double. So I always think of it that way, 1 less than double. So double of 6 would be 12, 1 less than that is 11. So that's how I help remember all of these things in my unit circle. This is the kind of thing that you'll be seeing on your quiz on the unit circle. You will have to be able to recreate this. So we have to be able to evaluate these without a calculator. So if you think of 30 degrees, or your pi over 3 here, pi over 3 is your 30-degree angle. So if you remember, we had those special triangles. The hypotenuse was 2, the height here is 1, and that's the square root of 3. So if I want to find the sine here, it would be opposite over hypotenuse, which is 1/2. Now, going again, if you're looking at pi over 4, we're at the middle. Pi over 4 is the same as 45 degrees. So our sides were 1, 1, and the square root of 2. So cosine would be 1 over the square root of 2, or the square root of 2 over 2. Oops, I did this first one wrong. Sorry. I did 30 degrees. Actually, that does not go with 30 degrees. We have to do 60 degrees. So let's change that. So that means this is 60, this is 30. Again, the hypotenuse is still 1. This is or hypotenuse is 2. That would be 1, that would be square root of 3. So that should be square root of 3 over 2. So you have to kind of draw these in each quadrant wherever they're located. So for instance, if I skip down here and I'm looking at that 5 pi over 3, I know is down here in the fourth quadrant. Its reference angle, if you look at the bottom, since the bottom is 3 and we know pi over 3 is 60 degrees, our reference angle here is 60 degrees. So if we fill this in again, we have 2, 1, and the square root of 3. So tangent is opposite over adjacent. So square root of 3 over 2, but we're going down here. This should actually be a negative. And so what you'll need to remember as you're going through and filling these in is all of your functions are positive here. Sine is positive, tangent is positive, and cosine is positive. And their reciprocal functions are as well. So cosecant, secant, and cotangent. Okay, so those are the quadrants in which they are positive. So if you're looking at tangent in the fourth quadrant, it's not cosine, it's not secant, so it has to have a negative answer. Now, the way I have my students remember this is all students take calc. Okay, all functions are positive, sine's positive, tangent's positive, cosine's positive. So all students take calc. So just another thing to remember. One thing also that you might want to do, oops, let's see if I can add a slide here. Another thing that this textbook asks you to do is know what are your odd and even functions. So an odd function, if you go back to thinking of what you did in maybe a college algebra class, an odd function means that, oops, let's do even first. F of x has to equal f of negative x. So that's what an even function is. An odd function says negative f of x has to equal f of negative x. So these things have to be true in order for them to be odd or even. And it kind of works that way with trig functions as well. So with your trig functions, cosine is considered an even function. That means cosine of t equals cosine of a negative t. And an odd function would be like sine. So sine of t is equal to negative, or sorry, sine of negative t is negative sine of t. Okay, so you can kind of see how the stuff that you did in college algebra is still going to work here. Tangent is also an odd function. So you'll need to know a little bit of that as well. The other part that you have to be able to do is to be able to use the calculator. What you need to remember is that if you are using a calculator, if your angle is in degrees, make sure your calculator's in degrees. If it looks like this and it has no degree symbol, that means you're in radians. So make sure your calculator's in radians. If you see a pi in it, you're in radians. So you're just going to enter these in the calculator to get those values. If you have cotangent, remember that's equivalent to 1 over the tangent of that same angle. So cotangent isn't a function on the calculator, so you'll have to type it in that way. Same thing here, 1 over the cosine of 28. You have not done degrees, minutes, seconds, so you won't have to really worry about that. But you do have somewhere you have to type in the calculator. So I know this was a very quick lesson. If you do have questions, make sure that you reach out and ask. Have a great day.